Hello everyone. Today we'll be solving the problem number 1 to 8, longest consecutive subsequence. So you can just go through the question and also we can just go through the example as well. So I'll just summarize the question for you so that it will be easier to understand. Along with it, let's discuss the this one approach, edge cases, and then let's write the code. Finally, discussing about the time and space complexities, right? So first thing, what I'll be doing here is let's understand what the question states here. So we are tasked with finding the longest length of the longest sequence of consecutive integers in a unsorted array. So the array is unsorted. This is not a sorted array. You can clearly see here. We have to find the length of the longest sequence of consecutive integers in an unsorted array. So we have to find the longest sequence of consecutive integers, right? So the sequence must contain numbers in increasing order. So this is very important. Again, I'm telling the sequence must contains the sequence must contain the numbers in increasing order. This we have to keep in mind. This is very important. So again, I'm telling the sequence must contain numbers in increasing order, but the numbers can appear in any order in the array. It can appear in any order in the array. So they have said that it can appear in any order in the array. The solution should run in big of n time complexity. So they have strictly mentioned that the solution should run in big of n time complexity, right? So this can be of any order, as well as one more thing, the solution should run in big of n time complexity here. So the sequence should contain the numbers in the increasing order they have mentioned. Here we can clearly see it is of 1, 2, 3, 4, right? So we can clearly see here 1, 2, 3, 4. 5 is not there. So we have to get the output here 1, 2, 3, 4. The length is here 1, 2, 3, 4, 4 itself, right? So that's what they have given here. So the output 2 here, the example 2 they have mentioned here 0. This one is from 1 to 9. 0 has been repeated twice here. Let's ignore this one. So let's consider 0 to 9 here. 0 to 8, sorry, here. 9 they have not given. 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0 to 9 is of length 9. It starts from 0, right? So the output should be length. Output should be of the length 9. So that's what they have given here. So let's discuss the approach first. Then let's go with the edge cases and then write the code. So let's discuss the approach step by step. So we'll be making use of the hash set here. So just keep in mind, we'll be making use of the hash set here. Why we'll make use of the set here? To store all the unique numbers from the input array. We are storing the unique numbers from the input array. So we'll be making use of the hash set. This allows constant time checks for the existence of the number. So just keep in mind, we'll be making use of the hash set to store all the unique numbers from the input array. So, and the second step, let's move to the second step, nothing but the iteration. So while I say iteration, so we are iterating through the each number in the set. So we will be iterating through the each number in the set right here. So first what we will do, we'll check if the number is start of the sequence by confirming the number 1 less than 1 less is not in the set. Suppose there is 100, we will check whether 99 is present in the set or not. So that's what we'll be doing in the first case. If the number, this is just for the example sake, just consider this for the example sake. If 96 is present, we will check whether 95 is present in the set or not. That's what we'll be doing. Just for the example sake, just consider this one. So what we'll be doing first here, we'll check if the number is the start of the sequence. How we will check this one? By confirming that the number 1 less is not in the set. Here we saw this one with the example, right? So the second step inside the iteration, we will check if the number is the start of the sequence or not. So how we will check this one? By extending the sequence by checking for the next consecutive numbers. So suppose if 3 is present, 3 is the start of the sequence, we will check whether 4 is present in the set. If 4 is present, we will check whether 5 is present. If 5 is present, we'll check whether 6 is present until the consecutive number is present, we will go on checking. That's what we do here, right? So I hope this is clear. Finally, we will track the length of the current sequence. So we will be checking until the length of the current sequence. So this is the second step. And third step, what we will do, we will update the longest sequence until the length, longest sequence length found so far. So we'll update, what we will do here, we will update the longest sequence length found so far. Longest sequence found so far. We'll update the longest sequence found so far, right? Finally, final step is we will return the longest sequence length. We will return longest sequence here, right? So this will be the approach that we'll be going with. So you'll understand very clearly while we write the code. Just keep this one in mind, right? So next we'll be discussing about the edge cases. Then let's write the code and we'll be discussing about the time complexity and the space complexity. So before moving on to the edge cases, we will consider this example and let's see according to the approach this works or not. So first one, we have considered 100, right? First what we'll do, we'll check the number before 100, nothing but 99. 99 is not present. So this one will be the first sequence. Then we will check for the next number, 101. So 101 is not present in the set. You can clearly see here, 101 is not present, right? So we'll ignore this one. Let's move to the 4. Next element. So 4, we'll check for the previous number, 3. So 3 is present in the this one. So this is not the starting element, right? So 3 is present. So this is not the starting element. So we will ignore this one. So let's go with the 200. So let's check whether 199 is present or not, the previous number. So previous number 199 is not present. So this will be considered as the starting number and we will check for the next number, nothing but 201 here. So 201 is not present in the array. So we will ignore this one. Next, we have checked for these numbers. Next, let's go with 1 here. So 0, let's check with 0, previous element. So 0 is not present. This will be considered as first element and we will go with the this one. Check for 2. 2 is present here. So we'll be considering here this one, 1, 2. Next, what we will do, for 2, we will check for the same thing. So next consecutive number, we will check for 2, nothing but 3 here, right? We will check with 3 now. So 3 is present in the array. You can clearly see here. So it will be 3 here. Finally, what we will do, we will check for 4. 3 was present in the array. So 3 is present in the array. So we will be we'll get 1, 2, 3 as consequence. Sequence. And finally, we'll check for 4. 4 is also present in the array. So we'll be having 4 here. So let's add 4 to the sequence. Now we have 1, 2, 3, 4. Next, what we will do, we will check for 5 after 4. 5 is not present in the array. So this one fails here. So the longest sequence is 1, 2, 3 and 4. So this is where, that's what they have provided in the example, first example. So please do check out for the second example as well. So this is the approach basically, right? So I'll just, let me delete this one and let's discuss the edge cases one by one. So I'll just come here, just give me a second. So let's discuss edge cases one by one. So first one is here, we will check for the empty array. So let me come here. Let's go with empty array. So here, while I say input, we will consider empty array, right? So the output will be 0 here. Why the output will be 0 here? Just give me a second here. The output will be 0 because an empty array has no elements. We have we don't have any element inside the empty array, right? So the longest sequence length is 0 here. We can clearly see here. So the output will be 0 here. So let's go with the second case. So here we'll consider single element. So input, let me consider here. Let's go with the single element this time. So single element is, let me consider some random number here. So the output will be 1 here. Why the output will be 1 here? A single number forms a sequence of length 1 by itself. We know this one, right? So the output will be 1 here. I hope this is clear. So next, let's move on with the next edge case, nothing but array with duplicates here. Let's go with array with duplicates here. So here, array with duplicates, let me consider here the input 1, 2, 2, 3. Let me consider this one. So the output here will be 3. So we will check the same thing. We will check for the previous number 0. 0 is not present. So this will be considered as this one, starting element. And we'll check for 2. Yes, 2 is present. We'll check for 3. And again 3 is present. As we are making use of the hash set, this one will be ignored, right? So the length will be 3, right? So this is for the third edge case, and the final edge case is no consecutive sequence. So I'll just come here. Let me consider the input 10, 30 and 20 here. So 10, 30 and 20, the output will be 1 here. So why the output will be 1 here? Each number is isolated, so the longest sequence length is 1. We don't have any particular number next to this one. Then we don't have 11 here, we don't have 31 here, and we don't have 21 here. Right? So the output will be quite obviously 1. This is for the no consecutive sequence. So the output will be 1 here. So we discussed here 4 edge cases. One was for the empty array, one was for the single element, and then one was for the array with duplicates here. This one, finally, one is for the no consecutive sequence, right? So let me delete this one. So just give me a second here. So let's start writing the code, and I'll just explain the code along with writing the code. So let's write the code and let's discuss the time and space complexity of the code, right? So I'll just come here. Let me quick come here. I'll just give here not of nums or length of the nums. If it is equal to 0, then we will be we'll just return 0. So what we are doing here, this is the edge case for the empty array that we saw, right? So if the length is 0, I mean if we have the empty array, we'll just return 0 in simple terms. So the next step is we have to store all the unique numbers in a set, right? So as we had discussed in the approach, we'll be going with the hash set. I'll just come here. New set. Let's pass the nums here. We have considered nums as parameter, right? So I'll just pass the nums as nums here. So next is we have to track the length of the longest sequence as well. I just come here. Let me give longest equals 0. So this is one thing. And finally, let's move to the main part, nothing but the iteration, the second step. So let's iterate through the each number in the set. I'll just give here let num of set here. So we will check if this is the start of the sequence. So for that one, I had already explained, we'll check for the previous number, right? So to check whether it is the start of the sequence, we will check for the previous number. I'll simply give here set dot hash for the previous number, nothing but we have considered num right here, individual num of set here in the for loop. So it will be num minus 1. This is simple. Next step, if this is the start of the sequence, nothing but I'll just give here current num equals num. If this is the starting number in the sequence, then we will we have to just give me a second here. Then the sequence starts with the current number. So we have to initialize first, right? So I forgot this one here. So I have to give here current length equals 1. So the sequence starts with the current number. After the sequence starts with the current number, we have to count the consecutive numbers in the sequence as well. So how can we write that one? If the first here in this case, so this was the first number, right? So we have to check for the next consecutive numbers 2, 3 and 4. So how can we write that? I'll just make use of the while loop here. While of I'll just give here set dot has let me pass the current num plus 1 for the next number. We are just incrementing the one number, right, to check for the next number. So let's increment the current num here, and also we have to increment the length as well. If we have found the next number here, in this case we have found the next number 2 here, we have to increment the length as well. So here we for the next consecutive number after 2 we have found the 3 as well, we have to increase the length as well, right? So I'll just give here, let's increment the current length along with the current number. If we find the current number, we have to increase the current length as well. So this is one thing. Let me format this one once. Finally, we have to update the longest sequence length. So before returning the result, we have to update the longest sequence length, right? So I'll just come out of the while loop. Let me give ya longest math.max. We need the longest sequence length, right? That is the reason I will be making use of the math.max here. So this will be longest, and I have made use of the variable name current length here, right? So I'll just give here current length. So let's finally let's return the result. I'll just give here result. Let me submit this one. What I've done? Oh, this one has to be th. Just give me a second here. I misspelled the current length. Result. We haven't. Oh yeah, this one has to be longest, not the result. So we haven't considered any result here, right? So longest I have considered here. This one. So let me return longest. Sorry, why did I give result? Anyways, so now you can clearly see the code got submitted. So the code works absolutely correct here, right? So first what I'll do, next what we'll do, let's discuss about the time complexity and the space complexity. So as we went with the approach hash set, right? Let's discuss about the time complexity first. So here the overall time complexity would be big of n. Why the time complexity will be big of n here? Each number is processed at most twice here. We know once for the set dot has, this one, once for the set dot has lookup, and once for the while loop, this one. So overall the time complexity would be big of n. I hope this is clear. Let me quickly give here big of n, and the space complexity would be big of n here. Why the space complexity would be big of n here? Because the set requires storage for all unique numbers in the input array. In simple terms, the space complexity would be big of n here. So I hope this is clear, right? So this is it. Thanks for watching, guys.